You've heard that earth-air tunnels can cool your home using just the ground. But most systems don't work as well as they should because of a few avoidable design mistakes. In this video, I'll show you the 6 most common errors people make and how to design a smarter, cleaner, and more efficient system. This video is sponsored by JLCMC. More on this later. The first and most common mistake, placing the tunnel too close to the surface. For effective cooling, the tunnel needs to be buried deep enough where ground temperature remains stable year-round. If it's too shallow, say, less than 1.5 meters, it'll absorb surface heat and won't cool the air effectively. Place the tunnel at a depth of 2.5 to 3.5 meters, depending on your climate. This ensures it taps into the Earth's constant temperature, around 18 to 22 degrees Celsius in many places. A pipe that's too narrow will cause high air resistance, but a pipe that's too wide can reduce airflow velocity and increase cost unnecessarily. A sweet spot exists. For small residential buildings, 150 millimeters to 300 millimeters diameter works well. For larger buildings or resorts, you might go up to 450 millimeters. The design should balance air speed, thermal exchange, and fan load. Good design also needs precise components. For moving parts in climate control systems, I use JLMC's ball screw B04. It's efficient, low friction, and built to last, perfect for controlling dampers, airflow valves, or automated louvers. High-grade materials, engineered for reliability, exactly what you want in any system. For more information, click the link in the description. Using metal pipes or poor-quality plastics can lead to corrosion, low thermal mass, or air quality issues over time. Use HDPE, UPVC, or concrete pipes. They're durable, have decent thermal conductivity, and resist corrosion. In humid areas, prefer materials that resist mold growth. One deadly mistake: not giving the pipe a slope. Water can accumulate inside the tunnel, causing mold, bad odor, and poor air quality. Always provide a 1 to 2% slope for water drainage. Add a sump pit or drainage outlet at the lowest point to collect and remove moisture. Over time, tunnels can gather dust, dead insects, or even small animals. If you don't include access points, cleaning becomes a nightmare. For every 15 to 20 meters, add cleaning or inspection chambers. These access points let you flush, inspect, or clean the pipe without digging it up. A common oversight: ignoring air filtration. If you pull outdoor air directly into your building without filtering, you bring in dust, pollen, and pollutants. Add an intake chamber with a mesh filter or install a pre-filter at the tunnel inlet. Designing an earth-air tunnel system is simple in theory, but details matter. Avoiding these 6 mistakes can mean the difference between a passive cooling success story or a failed, moldy pipe underground. If you found this helpful, don't forget to like, subscribe, and share this video with someone working on sustainable buildings.